Okay, section 3.4, part 1. What we're going to talk about in this first video is we're going to talk about one very important component that we often talk about whenever we talk about the slope of a line. About a line in general, is called the slope of a line. Now, let me give you some general information first. First of all, the slope of a line is exactly what you think it would be. It's the angle in which the line runs. It's just like if you're walking outside and you're walking up a road. You can be walking up a road that has perfectly flat. It can have a little bit of a hill, or it can have a real steep hill. Whenever we talk about the slope of a line, we assign a number to it. So the slope of a line is a number. And that number can be positive or negative. And so what I want to do first is just give you a general idea of what slope means. For instance, if I told you I passed a car on the interstate going 30 miles per hour, first thing you would think is, my gosh, they're going slow. And the reason is you have a point of reference for that. But if I told you they were going 95 miles per hour, you would know that's fast. So I want to talk to you about a line. What if a line has a slope 1? What if a line has slope 12? So in the slope world, what do those numbers mean? Let me get a little bit ahead of myself. In the slope world, if you're talking about a slope of 5, that is a huge slope. Average slope, what I refer to as what I call the perfect slope, is slope 1. Slope 1 is, if you remember from geometry, you got a horizontal line, you got a vertical line. Slope 1 is halfway in between those. So slope 5 means that your line is 5 times as steep. The bigger the number, the steeper the slope. The smaller the number, the flatter the slope. I'll explain why in just a minute. If a line goes uphill from left to right, the slope's positive. If a line falls from left to right, the slope is negative. If a line is perfectly horizontal, remember in the last section we said if it has just a y in it, if it's perfectly horizontal, that line has a slope of 0. Because 0 is the number that's between the positive numbers and the negative numbers. The only type of line that we do not discuss slope to, I'll explain this why also in a little bit, is a vertical line. A vertical line is the only kind of line we do not assign a number for. The slope of a vertical line is undefined. Again, I'll explain that in a few minutes. The easiest way for you to remember that is when we talk about slope, think about slope as something that you can walk on. Well, tell me what you cannot walk on. You cannot walk up a tree. It's vertical. So a vertical line is the only kind of line we do not give a slope to. All right, so what I want to do is first, I want to give you a geometrical definition for slope. From this point on, anytime you see the letter little m is the letter we use for slope. By definition, slope is defined to be rise over run. All right, so here's what I want to do. I want to draw a line that has a slope of, say, 4. Now, in order for us to do that, we have to have a starting point. So I'm just going to make up a starting point. Let's suppose my starting point was at the point 2, 1. Now, I could have put that starting point anywhere. Okay, so if my starting point is 2, 1, that means that point is right there. So let's suppose I wanted to draw a line that had a slope 4 through that point right there. Here's what we would do. Slope is defined to be rise over run. Well, remember 4 has a denominator understood 1. So if I put my pencil on the starting point, which could have been anywhere, if you want to see what a line of slope 4 looks like, start right here and go up 1, 2, 3, 4, and then go to the right 1. So rise is a vertical movement, up or down. Run is a horizontal movement. So you go up 4 and right 1, and then draw that line. So you think about walking on a hill that was that sharp or steep. That's a pretty big slope, isn't it? So slope 4 in the slope world is big. Now, let's suppose I had a slope 1. And I want to use the same starting point. So slope 1 would be 1 over 1. So that would be up 1 to the right 1. So I'd start right here. I'd go up 1 and over 1. That line right there has a slope 1. And that line has a slope 4. Now, what if the line is slope 0? Well, we've already talked about it, but I'm going to do it again here. 0 is understood to be 0 over 1. So this would be rise, none, run, 1. So if I use this same graph, go up none, go to the right 1. So you can see that that line is perfectly horizontal. So here's what you've got. You've got a 0 slope. This is vertical line. 0 slope, so 1 slope's halfway. That's this one right there. It's right there. Slope 4 is really steep. Now think about what slope 50 would be. That would be up 50 over 1. Well, gracious, that thing would be almost vertical. It wouldn't be vertical, but it'd be almost. What about slope 5,000? Up 5,000 over 1. It's even more vertical. So you can see now why a vertical line has an undefined slope. You could actually say that a vertical line has an infinity slope. It is so astronomically large that we can't assign a value to it. So it gets bigger and bigger and bigger and bigger and bigger, and it just gets infinitely large. We just don't call it infinity. So the slope of a vertical line is undefined. Now, what if it said the slope was 2/5? Well, that's a small fraction. So this line should be pretty flat. So that means, and I know this is getting jumbled up, but you can still watch and get the point. So if I start right here, that means go up 2, 1, 2, and over 1, 2, 3, 4, one more, 5. So that line right there would have a 2/5 slope. You go up 2 and to the right 5. Now, let me start a new graph. So suppose a line had a slope of, say, -3. And just for convenience sake, let's use the same starting point. So what this would mean is, there's my starting point. If slope is -3, that's -3 over 1. So what that mean would be rise would be down 3. Right, the word rise just means vertical. Like when you get on an elevator, you can go up or down. So your rise is either up or down. So if this is -3, you go down 3. 1, 2, 3. Now you count this one. 1, 2, 3. And then you go over right 1. So look at that line. This is my X and Y axis. What is the difference in this line than all of the others? This line falls from left to right instead of rises. That's why I said a while ago that a slope that's negative goes down from left to right. Now, let me make one more comment. Let's suppose I had a negative 2/5 slope. Rise over run. if you have a negative 2/5 slope, this negative does not apply to both of these numbers. Why not? Because if you apply the negative to both of the numbers, what is a negative over a negative? It's a positive. So this negative does not apply to both of these numbers. Now you could apply it to either one, but here's my suggestion. I would always apply the negative to the top number. So my rise may be positive in some problems, negative in some problems. But my run, the way I do it, is always positive. So my run then would be always right. So when I would read this, I would say rise -2, that would mean down 2, run +5, right 5. And if you notice, and I meant to say this a while ago, when I go down 2 and right 5, I always do it from the point that I'm given. So go down 2 and right 5 from the original point. So if I come back to right here and go down 2, 1, 2, and then I got to go over, down 2, and over 1, 2, 3, 4, 5. And then draw my line. Now, one common question I have students ask is, they'll say, Mr. Rayner, when I go, if I wanted to put the negative here, could I go up 2 and then left 5? Yes, you could. If you come right here and you go up 2 and left 5, you're just going to get another point over here. So sure, you can apply that negative to the bottom and not to the top, but don't apply it to both. But again, my suggestion would be just apply it to the top number always. So slope 0, slope undefined, slope 1. Steeper the slope, the bigger the number. So this is 1, 2, 3, 4, 5, 6, 7. It gets bigger and bigger. All of these slopes are fractional. Now let's talk about the negative side. Slope 0, undefined slope. This would be -1 slope. So -1, -2, -3, -4, -5. Anything below it is negative fractional slope. And that's the idea of how slope works. So the main thing I want you to take from it too is that, of course, slopes rise over run. But I want you to know that a line that goes uphill is a positive slope. Line that goes downhill is a negative slope. Vertical line has an undefined slope. A horizontal line has a 0 slope. Slope of a line. Okay. Now, let's start out and take this next note down. Pause this note as you need to. I will pause as well to give you some places to write this down. So here's the note. Given any 2 points on a line, we can find the slope of this line by labeling the ordered pairs x1, y1 and x2, y2, and then use the slope formula, which is, and then here's the slope formula. Okay, first thing I want to say about this formula before we get very far into it at all. Number one, you must memorize this formula in order to use it. Okay, let's look at some examples now by using the slope formula. So write these instructions down. Instructions here, find the slope of the line, write this down, find the slope of the line that passes through the 2 given points. Find the slope of the line that passes through the two given points. Okay, here's what I'm going to do. I'm going to put the whole problem up. Once you see this entire problem, pause the video and write it all down. And then after you write it all down, mash play, and I will go over it with you. So, pause the video now. Okay, I'm assuming that you've done this now, so let me go back over it. So here's what we do. The instructions here says, find the slope of the line that goes through these 2 points. 1, 3, and 7, 4. All right, the first thing we do is this. Every ordered pair is always a XY. So this is a XY. This is a XY. But since this one's listed first, I'm going to call it X1, Y1. Since the second point is listed second, I'm going to call it X2, Y2. Now, I'm going to write my slope formula down. Couple of things. First, when you write this formula down, make sure you always put the Y's on top. X is on bottom. Secondly, make sure you put, you could do Y1 minus Y2 if you wanted to in the top, but if you did, you'd have to do X1 minus X2 in the bottom. All right, then all you do is just take these 4 numbers and plug straight in. So 4 would go right here, 3 would go right here, 7 would go right here, and 1 would go right there. So just make sure you don't put the numbers in the wrong spot. And then when you plug that in, that's where you get the answer, 1, 6. And you've already copied that down. Now, let me show you something right quick. You don't have to graph this. If I plot 7, 4, it's right here. If I plot 1, 3, it's right here. Now, watch how I go here's my line right here. Watch what happens if I go from right here to right here. How do I get there? I go up 1 and then over 1, 2, 3, 4, 5, 6. So I went up 1 and over 6. And that's the slope that we got. If you plot those 2 points. I'm sorry, that's not exactly straight, but you get the idea. So you say, well, Mr. Runner, if I can just plot the 2 points and count the rise over run, why don't I just do that then? The reason we don't teach it that way is, what if those 2 points are really, really far apart? You know, what if they're like -2, 27 and 43, -95? You know, those are too far apart. Okay, so let's do the same thing again to this problem. Pause the video now. Pause the video now. And copy it. Okay, I'm assuming you paused the video and copied it. If you didn't, back up and copy it. Okay, so we're going to do the same thing here. We're going to call the first point X1, Y1, second point X2, Y2. Then I'm going to write down my formula. And then I'm going to plug the numbers straight into the formula. Now be careful here. Y2 is -5 minus Y1 is 2 over X2, which is 1, minus, and then X1 is -3. Yes, you have to put 2 negatives. Well, we talked about that in the very first section. Double negatives gives me a what? Positive. So this is going to be -7 over 4. And that does not reduce, so that is my answer. All right, we're going to do 2 more. Okay, pause the video and copy this now. Okay, I'm assuming you paused the video where I told you to pause it. Now let's do the same thing. We're going to call this x1, y1, x2, y2. Going to write down the slope formula. And then y2 is negative 1 minus y1 is another negative 1 over x2, which is 5, minus x1, which is 3. Double negatives gives me a positive, so that gives negative 1 plus 1, which is 0, over 2. First day of class or first video or second video, 0 over any number is 0. So that means that this line must be horizontal because the slope's 0. That would also mean that the equation has just a y in it, not an x. If you plot those 2 points, which I'm not going to do, you will see that they're straight across from each other. All right, last example. Pause the video now. Okay. Now we've got the ordered pairs. We label. We write our formula down. Then we plug our numbers straight in. But remember here, when you get down to right here, you end up with 3 over 0. Remember those saying 0 below, no go? If you have division by 0, that's no solution, or we call that undefined. So, if the slope is undefined, that means that this line must be vertical. And it is. If you plot these 2 points on a graph, you'll see that those 2 points are straight up and down from one another. So that one has an undefined slope. So that's how you find the slope of a line if you are given 2 ordered pairs. Okay, that concludes this video, section 3.4, part 2.